Hi, this is the Advancement of Navigation, and my name is Ashwin Ravi. This presentation will be on GPS navigation and its prospective future. So for this presentation, I've used Microsoft PowerPoint to write up the slides, and then I've used the Jing application to record the audio, and then export both the audio and the video together as one. So a GPS is a satellite-based navigation system widely used around the world. Satellites determine a person's position relative to the Earth and consequently allow them to map routes to any other location with remarkable precision. The satellite also helps monitor weather, traffic, and other conditions subject to change, delivering real-time insights to GPS users everywhere. GPS technology was originally designed for military use, but soon spread to other areas after people quickly realized the benefit. Now GPS technology is heavily invested in from wealthy individuals in most fields. GPS technology is found in home-based devices as well as mobile devices, delivering satellite-obtained mapping information wherever an internet connection is present. So the way GPS works is that the system itself refers to a network consisting of about 30 satellites that take up different orbits around the Earth, so they all have different paths. The satellites broadcast radio signals at regular intervals containing data relating to their current position around the Earth. Signals are intercepted by the GPS receiver unit in a user's device, which determines how far away each satellite is based on how long it takes for the signals to arrive. So if a satellite is further away in the Earth, in Earth's orbit, then it will take longer for the signal to reach your device. The GPS receiver inputs the location data from at least 3 satellites and then calculates the user's position using the process known as trilateration. So trilateration starts when a GPS receiver first obtains the location of at least 3 satellites. So we can start, we'll work our way up. We'll start from 1, then go into 2, then go into 3. So the position of a user based on one satellite is essentially a wide range on the surface of the Earth, a range that can be described as round, just the area that the signals are transmitted through. Once data from a second satellite is obtained, the user's possible location range is narrowed down to the overlapping area between the 2 separately positioned satellites. Finally, once data from the third satellite is obtained, the intersecting area from between the 3 satellites is narrowed down to what is no more than a point. This very same concept is translated to spheres when you're dealing with the Earth, which is a very 3D object. So you can see from this diagram here that one satellite, you have not that narrowed of a location range. 2 satellites, you kind of have the intersecting area between 2 circles. So you have a much narrower location range. And then when you get to 3 satellites, it's basically just a point. So that's about as precise as you can get. And the key takeaway here is that the more satellites there are in orbit and transmitting signals, the improved precision of location determinations. So the more accurate that they will be and precise. So GPS has the ability to form optimal routes from location to location based on a user's request. So the way it does that is it first utilizes a shortest path algorithm, a common programming method that instantly calculates the shortest distance from one point to another on a graph. And in this case, our graph is a map. GPS also considers real-time traffic info provided by the satellite network, information which is determined based on speed data gathered from local GPS receivers. So a bunch of cars in traffic, the people in said cars, their phones will be providing said data. And that's real-time traffic information. Each of these ideas above are implemented together to generate the ideal travel route for a user, with most means of travel being accounted for and included as options. So you'll usually see routes for bike users, for bus goers, for bicyclists, and so on. So the advantage of GPS is that before the days in which GPS was prominent, people had to rely on physical maps for navigation. and they traced what they believed to be the most optimal routes to a destination based on rough eyeballing and estimation and word of mouth. And that is not necessarily the most optimal way, the most effective way. And in the area just prior to the modern era, people had the ability to use MapQuest, a software that became the first mapping application to use the shortest path algorithm, enabling users to print a calculated route before embarking on their journeys. So that had its disadvantages as well, because you couldn't alter your route, you couldn't change your plans midway through. You're kind of just stuck with what you have printed out from the get-go. Both of these options can and should be commended for their usefulness during their respective peaks, because people still had to get around before these technologies, and that was a significant part of our history. But after studying these archaic methods, it only goes to show the effectiveness of, only goes to emphasize the effectiveness of GPS. And it was a huge step to the future, no doubt. GPS-3, looking ahead now, is the class of new satellites set for full launch in 2023. New satellites have an improved lifespan of 15 years, twice the length of current satellites, which live for 7.5 years. GPS-3 has already deployed 2 satellites and has 8 more in various stages of development. Current GPS provides location precision of 5 to 10 meters, so wherever you are, you can be sure that your phone is telling you the right location by about a 5 to 10 meter range. GPS-3 will have a new precision of 1 to 3 meters, so that's much more precise, as you can see. No doubt helped by the fact that there are more satellites in the sky, higher quality satellites at that. And finally, GPS-3 signals will be compatible internationally with satellites from all other countries, something that did not exist before. So GPS has an equivalent in other major countries, called by different names, and now our satellite signals are compatible with theirs. So we are basically granted more effective communication internationally. They will also transmit military signals with a much stronger encryption code than GPS used today. Lockheed Martin will handle all jobs related to the launch and subsequent operation of GPS-3 satellites. And here are the references used for this project. Thank you very much, and goodbye.